Welcome to Kenton Teaches. Enjoy the video.
You start by organizing your dataset and environment. Prepare images and labels in Coco or Yolov8, then split them 80% train, 10% val, 10% test so training is valid. Once done, install Python 3.8 or later and Ultralytics Yolov8. Make sure GPU drivers and CUDA match your PyTorch version. This gives you reproducible results and avoids later compatibility pain. Now connect your data YAML to the repository and verify one batch runs without errors before moving on. You configure the model and training parameters next. Pick a model size, Yolov8n for speed, Yolov8l/x for accuracy, because larger nets learn complex features but require more compute. Then set epochs, batch size, image size, and a sensible learning rate. Once set, enable augmentation and transfer learning from a pre-trained checkpoint to converge faster. Use mixed precision and gradient accumulation if memory is limited. Monitor loss and MAP during training, so you can adjust hyperparameters mid-run if necessary. You finish by validating and exporting your best model. Run validation to inspect MAP, precision, and recall per class, and examine qualitative predictions to catch label or augmentation errors. Once satisfied, export to ONGS or Core ML for deployment and test inference on real images. If results are poor, try one key troubleshooting tip. Reduce the learning rate and add more varied training data. Also double-check labels for misalignments and remove extreme augmentations that distort objects. This fixes most training.
Thanks for watching. Please subscribe if this video was helpful.